Hi, I'm Juan Loaiza, and I'm excited to talk about how we're rethinking database architecture to embrace modern app dev. Now, app dev paradigms are in a rapid state of transformation. Modern app dev paradigms are simplifying and accelerating application development. For example, they're simplifying how you deploy apps, simplifying how you architect apps, and simplifying how data models and data analytics are used. However, these app dev paradigms can greatly complicate database architecture. For these app dev paradigms to succeed, database architecture must be rethought. This presentation explains how Oracle's decentralized database architecture embraces modern app dev. Now, modern app dev transformations go beyond technology changes. They transform the way that technology teams are organized. They're part of a broader macro trend toward decentralization of apps, app dev teams, and data. Centralized and decentralized organizations each have their benefits and drawbacks. For example, centralized IT has the following benefits. It's much more efficient, consistent, and it reduces risk. Decentralized IT has its own benefits. There's a lot more focus on the product, outcome orientation, and agility. IT organizations traditionally favored centralization of teams and technologies. Oracle's famous for its leading data tech that supports centralized architectures and orgs, things like consolidation of mixed workloads, fault-tolerant availability, highest security, transparent scaling, comprehensive data model support, and powerful analytics. These technologies are focused on centralized architectures, but they're also key for decentralized architectures. Recently, IT has been moving to more decentralized organization models. The goal is to have smaller, more agile, more focused teams who own solutions end to end. The move toward decentralization has been enabled by modern app dev technologies. For example, app dev simplification technologies enable functional IT teams to be combined into DevOps and decentralized by product. And API and event-driven app dev technologies enable teams to be further decentralized to focus on product-specific microservices instead of full applications. Also, decentralization is promoted by data mesh architectures. In a data mesh, domain data is published as a product to consumers. The formats and publishing are owned by decentralized domain experts, not by centralized technology experts. As apps and app dev teams become more decentralized, data also becomes more decentralized. This can greatly complicate the database architecture. Decentralized IT is more outcome-centric and can deliver solutions faster. However, it has inherent trade-offs that need to be mitigated and minimized. Decentralization of IT can create waste like duplication of effort and proliferation of technologies. It can also fragment and data and have it diverge. Decentralized IT can also increase risk, security risk, availability risk, and quality risk. Outcome-focused teams tend to emphasize do it fast versus do it right. Oracle's strategy is to provide the best data technology for both centralized and decentralized architectures, to increase the agility of centralized and reduce the waste and risk of decentralized, to enable IT leaders to choose either alternative or a hybrid of both based on the needs of the business, not based on the limitations of the underlying technologies. This presentation describes Oracle's data technology that facilitates both centralized and decentralized app dev. However, I'm going to focus on our decentralized database architecture that facilitates app dev techniques like DevOps, microservices, and data mesh, since those are especially challenging for data architecture. Okay, so first let's talk about how Oracle simplifies decentralized deployments. Decentralization requires technologies that are simple to deploy and to operate. An example here is that the complexity of power plants requires power generation to be centralized, whereas the simplicity of solar panels enables power generation to be decentralized. Similarly, delivery of tech building blocks as simple to use API-driven services enables tech decentralization. Oracle's decentralized database architecture makes decentralized app dev radically simpler to deploy and use. And I'm going to go through 5 ways that it does that. First of all, let's talk about containers. So containers simplify deployments by enabling rapid and lightweight deployments of logical systems instead of physical systems. Oracle implements the container concept natively inside the database. You can deploy a lightweight, pluggable container database instead of deploying and managing physical databases for each microservice. Many pluggable databases can be deployed in a single physical database to simplify ops and manage many as one. Pluggable databases can be easily cloned and moved between physical databases for agility. And we've just eliminated all the limits on pluggable databases in Database 21CXE. Okay, next, let's talk about Docker containers. You can now easily use Docker containers to simplify the deployment of physical databases on which your logical databases are based. Oracle is now providing pre-built Docker container images for single instance, rack, and sharding. And Oracle also publishes the Docker files used to create these images on GitHub. So you can use the Docker files to build images for your specific database version and patches. Next, we'll talk about Kubernetes. So Oracle provides the ability to simplify the orchestration of database deployments using Kubernetes. Oracle Kubernetes Operators orchestrates the pluggable container databases, create, delete, clone, scale, patch, etc. Oracle provides help charts on GitHub describing the database structure. This enables complex configurations like sharded databases. Kubernetes tools and dashboards can monitor and trace the complete app. Okay, now let me talk about full database as a service using our Exadata database service, which runs the world's best database platform, Exadata. The Exadata database platform automates and optimizes all database infrastructure from the hardware up. It provides user-controlled database automation, elastic scaling, and pay-per-use, and you can deploy it in the public cloud or in your own data center with Cloud@Customer. And finally, for the ultimate simplicity, you can make your database self-driving, self-securing, and self-repairing using Oracle Autonomous Database. Here, Oracle takes over generic database management, allowing DevOps to focus on application-specific data modeling, security, performance, etc. And again, you can deploy these in the public cloud or in your data center with the Exadata Cloud@Customer. And for JSON-centric workloads, you can use Autonomous JSON Database. So the big picture on this simplification is that Oracle's decentralized database architecture makes decentralized apps simple to deploy and operate. All right, we've talked about deployment. Now let's talk about how Oracle makes it simple to architect decentralized apps. So our unique decentralized database architecture makes it simple to use decentralized app dev techniques like coded events, data events, API-driven development, low-code, and geo-distribution. I'm going to talk about these one at a time. So first, let's describe how decentralized apps are implemented. Decentralized apps are implemented using asynchronous events to initiate app and cross-microservice actions. For example, publishing a process this new order event can cause multiple microservices or app to take action. And events are published using event platforms like Kafka. Event handlers are usually hand-coded by developers, and this is what we call coded events. Event handlers implement actions, they change database state, and they produce other events. Now, ensuring event handlers preserve data consistency across different services is difficult because they must handle issues like process and network failures, concurrent changes, restores from backup, and disaster failovers. And any data divergence tends to cause additional divergence over time. Even if we ignore cross-database service consistency, maintaining consistency between a stateful event platform and a single stateful database is difficult. Most event platforms require developers to hand code consistency and failure recovery into every event handler. For the case of a simple publish or consume, the developer has to manually track the state of event consumption and store it in the database. For more sophisticated cases involving multiple events and database operations, maintaining consistency requires enormous amounts of error-prone work. Now, this can all be solved with transactions. The benefits of atomic transactions are well understood, but they're often forgotten. NoSQL databases initially claimed that transactions were unnecessary and in fact harmful. However, the users of the NoSQL databases learned through experience that coding data consistency in the app is error-prone and time-consuming. Newer versions of Kafka support transactions, but only inside the event platform, not between events and data. So Kafka works well for events between heterogeneous services that don't support transactions. But for homogeneous events within or across Oracle databases, it's much simpler and more reliable to use database native transactional events, which is what I'm going to talk about next. So Oracle has a feature called Transactional Event Queues, or TEQ. That's a free event platform that's built into the Oracle database. And this platform has been continuously enhanced for over 20 years. It was previously called AQ, or Advanced Queuing. TEQ is used by tens of thousands of enterprise customers today. TEQ makes developing decentralized apps much simpler. You can publish or consume events in a transactionally integrated way with data changes, so the whole thing is atomic. It handles the difficult cases like events that change database state and produce more events, and it provides exactly one semantics without the two-phase commit and item potency headaches. Also, security, backup, recovery, et cetera, of events and data are tied together so they never diverge. It's a scale-out architecture that can process over 1 million events per second. And TEQ implements reliable propagation of events across different Oracle databases without any of the headaches of two-phase commit. And you can use Confluent connectors to propagate heterogeneous events between Kafka and TEQ. Okay, so we've talked about coded events, but events fall into two categories. There's coded events and there's data events. So let's talk about data events now. Data events are state changes. For example, a change in the price of an item that's for sale. And these state changes are published to keep Peer microservices synchronized, to inform other applications, or to enable creation of data mesh domain events for consumption by OLTP or analytic systems. Applications can use Kafka to publish and consume the data events, but if they do so, it requires hand coding of state change capture by producers and hand coding of state change applied by consumers. This makes it difficult to keep data consistent, and it's also a very labor-intensive, fragile, and hard to parallelize process. In addition, it precludes the direct use of SQL to quickly and easily implement ad hoc changes and batch. All the state changes must be coded in order to capture and to be captured and propagated as code events. You can't use SQL at all directly. So instead of hand capturing and applying data events, you can use Oracle Golden Gate to automatically capture the data events from all leading database apps and platforms. It optionally transforms, enriches, and analyzes data events with a streaming platform. And it publishes the enriched data events to event platforms like Kafka, or it can directly apply data events to hundreds of different target types. The entire process is automated, parallel, and transactional to ensure both high performance and consistency. So Oracle Golden Gate solves all these difficult problems automatically. This makes Golden Gate the ideal underlying infrastructure for developing a data mesh. Golden Gate is very mature. It's the market and technology leader for data events and replication, and it's trusted by thousands of enterprises, including 80% of the Global 100. All right, so the big picture for events is that you should differentiate two kinds of events: coded events and data events. For coded events, we recommend you use transactional event queues within Oracle databases to benefit from transactional consistency. You can use Kafka connectors to transfer coded events between Oracle TEQ and Kafka for heterogeneous systems and services. For data events, we recommend using Golden Gate to publish and consume events in real time automatically between microservices, between apps, between public clouds enabling multi-cloud, and between operational analytic systems, and also to enable data mesh. All right, we've talked about events. Now let's talk about API-driven architectures. Decentralized apps often use REST APIs for communication. And Oracle makes this super simple because we have a feature called Oracle REST Data Services that automatically generates a REST API on top of any SQL statement or stored procedure. These REST APIs are free and they support OpenAPI, OAuth, pagination, filtering, logs, and connection pooling. So it's full featured. It handles all the different things you want. It unifies the application APIs with the data APIs, making decentralized apps much easier to develop because you're using a unified REST API. It also enables you to implement data as a service by publishing data using these REST APIs. Okay, next, let's talk about low-code. Oracle has a free Apex low-code IDE that dramatically simplifies app dev, enabling app dev decentralization. With Apex, enterprise apps can be generated rather than coded. Apex unifies the app tier and data tier. This increases agility by eliminating all the headaches of coding and managing middle tiers. You don't have to worry about app tier state or connection management or mapping app types to database type. All that is completely eliminated. The low-code simplicity of Apex also enables tech-savvy domain experts to create their own apps or data mesh data products, further decentralizing tech. Apex apps use the REST data services that I just talked about to communicate with other decentralized apps. Apex is an extremely popular low-code system. We have over 2 million Apex apps that exist today that customers have built, and 3,000 more Apex apps are developed every single day. Finally, let me talk about geo-distribution using database native sharding. So Oracle's native sharding makes it simple for apps to provide geographic data distribution or massive scale. It does so because it breaks a centralized database into a farm of smaller decentralized databases. And these shards can be located in different countries to satisfy data sovereignty. Shards are fully isolated from each other, which provides linear scalability of both data and users. An Oracle database automatically routes SQL based on the shard key to the correct shard, or if it crosses shards, we automatically execute the SQL across the shards. Also, we handle the toughest problem in sharding, which is online addition and reorganization of shards. So you get all the benefits of sharding with all the benefits of a mature SQL database. Oracle Database Native Sharding is used by many of the largest internet providers and telecoms in the world today. All right, so the big picture is that decentralized apps can be made dramatically simpler and more reliable using Oracle Decentralized Database Architecture. Finally, I'm going to describe how Oracle makes it easy to use modern data models and workloads in decentralized apps. So Oracle Database is a converged database that provides best-of-breed support for all the different data models and workloads that you need. This includes relational data, JSON and XML documents, machine learning, graph analysis, text search, spatial query, and blockchain. All the data types and workloads are built into the database, so you just call SQL to use them. And a single converged database is far less effort and risk to deploy, secure, and scale and operate than multiple single-purpose databases, one for each data model or workload. The single converged database also avoids having to move and reconcile data between databases, which is very complicated. You use the same SQL, REST APIs, and transactions to operate across all data types and workloads, which makes it dramatically simpler. It also dramatically simplifies app dev and ops, enabling small decentralized teams to use modern data types and workloads. Right, so again, the big picture is that by limiting the complexity introduced by single-purpose data stores for microservices, Converged Database dramatically simplifies decentralized app dev. All right, I've talked about the technologies. Now I'm going to give an example of how these simplify app dev. The example I'm going to use is of an online store. So these kind of applications were traditionally built using one monolith application running against one monolith database. But the microservice architecture is very different for the online store. The app architecture and database architecture are completely decentralized. The application is broken into 5 microservices, and each microservice uses multiple single-purpose databases, one for each data model or workload. Asynchronous coded events are used to implement app logic or actions that span the microservices, and code events are propagated at the app level using event platforms like Kafka. When you have changes in data, you again use coded events to propagate the data and changes between microservices. Now, how does Oracle simplify this architecture? So the first step is we replace multiple single-purpose databases within a microservice with a single converged database. It's much easier to tune, secure, scale, and troubleshoot microservices that use a single data store. And of course, you don't have to manage all the data stores either. The next step is to containerize the converged databases into smaller number of physical databases using pluggable databases. This allows you to manage many databases as if they were one. And you can orchestrate the pluggable database operations using Kubernetes operators. Next step is to implement coded events using transactional event queues wherever that's possible. With the transactional event queues, events and database changes execute in one atomic transaction, making them dramatically simpler and more robust. You can continue to use Kafka for heterogeneous events. The next step is to use Oracle Golden Gate to transactionally publish and consume data events between microservices, apps, and clouds. This eliminates the need to hand code, capture, and apply of state changes. And an app can have both coded events and data events, and Golden Gate can publish data events to Kafka. The next step is to use low-code Apex to generate the majority of the enterprise apps or microservices instead of hand coding them. The complexity of separate app tier and data tier is also eliminated by using Apex. And then the final step is to use Oracle Exadata Cloud Services to automate and optimize the entire database infrastructure. And you can run this either in the public cloud or on premises. And then you can deploy Oracle Autonomous Database on top of that to make your databases self-managing, self-repairing, and self-recurring. As you can see, rethinking database architecture to embrace modern app dev results in a dramatically simpler and far more robust application. You can get more information on this at developer.oracle.com/microservices. So here are the key messages from my talk today. First of all, modern paradigms simplify and accelerate app dev, and they promote decentralization of both apps and dev teams. However, this decentralization of app dev complicates the database architecture. Oracle's strategy is to rethink database architecture to facilitate both centralized and decentralized app dev, to bring agility to centralized and reduce complexity, waste, and risk of decentralized. We do this by dramatically simplifying app deployments, simplifying app architecture, and simplifying the data models and data analytics. Thanks for joining me today.